focus first.
First, we need to make them.
Oh yeah, let's separate them actually. Yeah, that's a good idea.
So, is there a minimum separation?
Well, the minimum separation is when they make contact.
No, but you were saying like you wanted to really closer slowing because you didn't want it to break, right?
Well, it's not to avoid breaking. I didn't want them to make contact because they might bond.
Okay.
In reality, these wafers won't bond because they're too dirty. But if I had clean wafers, they could bond.
Oh, I see.
So we don't want to make contact before we've done the alignment.
I see.
Because we only want to make contact after we've accomplished alignment, so that when it bonds, it's in the right place.
I see.
Yeah. It's okay, and they're nicely in view. Yeah, actually, as you found the marks, you can probably just focus on the lower marks there. Ah, one other thing I didn't mention. So when we focus on the upper marks, you'll see that they're white.
Mm-hmm.
If we get the right level of focus, that black cross is a shadow of the upper mark on the lower wafer. So that can confuse you. So we need to ignore that one. Focus on the lower marks, which are those squares. So be aware that that can happen. You can see shadows and you can see reflections sometimes. So if you find that it's moving too far,
Maybe we should change
well, the step is already at 2 microns. So if you just do tap the button rather than holding it down. Just use a series of taps. When you're using a small step like 2 microns, bear in mind that you may have to make 2 or 3 steps before you actually see any movement because of the backlash in the motor.
It looks.
Maybe you need to rotate it.
Yeah, a little bit anti-clockwise perhaps. That's fairly close now, so I'd now focus back to the upper wafer and then bring the Z drive up, bring the lower wafer up until you can start to focus on both simultaneously. Keep going up. You're still 580 micron separation there, so you can afford to keep going up until it's 0.1, 0.2. Yeah, you got pretty good view of both there.
thought we should focus on the lower now.
Yeah, this mismatch in the focusing there is a little bit tricky to deal with. So we need to, when we've leveled the platen better, hopefully that will be alleviated. Yeah, that's good. You've got that pretty much straight away. Good job.
Which one? This one? This one? Or this? Yeah, which one?
So if on this right hand one we can work around the focus problem by if you put the square onto the cross. So yeah, if you adjust the size of the square now onto that cross, yeah. Do the same on the left, yeah. We focus that back down again. Might be going the wrong way there. There we go. That's it. Yeah, that's close to spot on. So the problem here is that my wafers, these marks aren't quite printed in fully accurate locations. So we can get reasonably good alignment, but we can't quite get perfect alignment with them. That's the problem with my demonstration wafers. But yeah, you've got the idea. That's they're lined up. That's good. Okay, so shall I mess it up again and then someone else can have a try? Yeah. Okay.
Want to do it? Which one is the fine focus? You know, this one?
The top one.
These cameras are fixed in their position. They cannot like rotate left or right.
Yeah, you could rotate them if you like.
No, but are they like fixed? Because this might.
They are currently fixed, but they're only fixed with these brackets here on the front. So if you loosen those brackets off, you can rotate that.
How do you do the image capture?
On this, you can't.
We can't.
No,
That's
that
only on
option's
the
not on
automatic.
this. It's not on this machine, that option. But if the option were there,
Yeah,
there's a little radio buttons about here.
yeah.
And they, sorry, I'm explaining to him. You're doing fine. You can display a stored image, a live image, or a merged image.
Yep.
So what you would do is focus on the upper wafer. There's another button underneath
Yeah.
home position there. You can see it's grayed out, store images. That allows you to store the image. Then you can focus on the lower wafer, which is separated. Then you can change the radio button to merged images.
Yep.
So it will show you the upper image with the live image.
Superimposed.
Yeah, superimposed.
How do you move the wafer itself up and down, right and left?
The lower wafer, space bar, and then hold down left or hold down right. So at the moment, you're not focused on it. If you look at the top of the left-hand screen, you can just
Yes.
see there's a shadow moving around.
I wonder what I'm focused on.
There you go. So if you're moving the manipulator and you're not seeing any movement, it means you're not focused on the lower wafer. See, I've been a bit mean here. I've moved it quite a long way out of alignment. So these
And to rotate it.
these squares are the smaller ones, so they live kind of over here with this smaller cross.
Okay.
And the larger marks, I've been mean and moved them off the screen. That's just on the top there.
And the rotation of the wafer is.
So no space bar and then right and left. That's it. So you need to rotate it clockwise by pushing right on its own at the moment. And bring the marks so that they're roughly level with each other on the screen. So that's pretty good. You've got them roughly positioned quite nicely. So now I focus back onto the upper wafer and then draw the square. Or maybe, yeah, no, zoom in now and then draw the square. Yeah, when you've got the image capture in operation, when you're viewing the merged superimposed images, when you move the manipulator, there's a delay in the picture updating. So the refresh rate goes from being like a live picture, it goes to like 1 frame per second. So you have to push it, wait, and then it moves, push it again, wait. So it's a bit more tedious to do.
That's all a frame grabber in the PC
Yeah.
when they have it.
I think it's done by National Instruments software. They sort of,
Yeah.
it somehow merges the images, but it's slow to refresh the image on the screen.
The tap on 0.25.
So if you're making step adjustments, it's not using, so this is a speed parameter, so that's what it uses if you hold the button down. If you'll make step adjustments, it uses this step, which is just a number of degrees per press. So I think you need to turn it clockwise, so right a little bit, just a few steps. Too far, yeah. Don't panic. Just keep going. There you are, it's moving. Stop.
Wait.
Yeah, so more or less, right? So now if you focus back to the upper wafer, you can move the Z drive up and actually have a look at both of them focused simultaneously. So in theory, they should be still within the square.
Is it just this one?
Just up, yeah, with no spacebar. You can hold it down to start with because you're 1.2 millimeter separated, so you can. It's quite slow to move. So you can just hold it down until this number comes to say 0.4, 0.3. You can see them starting to come into focus now. So yeah, if you focus back on the crosses, focus on the upper wafer. You can keep moving the lower one up. Keep moving the lower one up until they come into focus. You're still 400, 250 microns away from making contact, so don't worry, you're fine.
It's good enough? Or
Yeah.
more?
I think you've got it. You've got the idea. You've got the concept. You've got it how it works. I think that's probably about as accurate as you can do with my wafers. Yeah, it's good. When you make contact, yeah, it can happen. If you use this central pin, it puts a small bow in the upper wafer. So then when the lower one comes up, it only makes contact with the central point, and that. Yep, that largely prevents contact shift. So if you've got the platens level and you use that pin, you shouldn't observe any shift when you make contact. If you do get shift, then you need to adjust the platen leveling. Okay, so I think we've picked up alignment quite quickly, that's good.
The what?
Direct bonding. Well, we'll do anodic bonding first, and then we'll do direct.
No, I mean in theory, in these conditions, in this environment, it's difficult to make.
To do a direct bond is difficult. We can try. I mean, what will happen is when we bring them into contact, they will stick. There'll be van der Waals interactions between the wafers, and they will stick. If you then try to anneal them, bake them out in an oven to get a proper chemical bond rather than a sort of electrostatic bond, then you would find that they'd fall apart, probably. But we can do the direct bond and we can observe them stick. But I mean, to get two wafers to stick together, if you've got two polished surfaces, you can just hold them, they'll stick. Then when you put them in the oven, they'll fall apart. But yeah, we're doing a anodic bond now. The anodic bond, I'm pretty sure, will work even in this environment. It's fine. But yeah, if you keep this area, if we give it a, like, use a vacuum cleaner and mop everything down and dust off all the surfaces, try and get rid of as many particles as possible, and then yeah, try to keep it as clean as possible. Ideally, we only have like this kind of clean room paper inside here, so no like manuals and other paper or cardboard, or all of these things generate particles that cause problems to direct bonding. And also, if you can get suits like this, like full suits with a hat and big overshoes, rather like boots, rather than just these kind of gowns, that would be helpful also. But yeah, for now this is okay. Right. Okay, so this is what I was talking about earlier. I have to toggle the exhaust valve because it doesn't think that the chamber's vented, even though it is. So now it will allow me to open the lid. Okay. So I'm going to put these wafers away.